Okay, so we have this question right here. It says in alpha particle scattering experiment, alpha particles were directed at a very thin gold foil. Some alpha particles were deflected through angles up to 180 degrees. Which of the following could explain this observation? Okay, so we have this very simple experiment here, okay? So this is our gold foil and alpha particles were directed at this gold foil, okay? And as you know, this gold foil is made up of gold atoms, okay? And inside those gold atoms, we have nucleus, okay? This nucleus is actually a very strongly, tightly compact, consists of multiple protons, okay? To be exact, it had 79 protons. 79 positively charged particles, okay? And as you know, alpha particle has two protons, okay? So it's positive 2 charge, okay? Now, when a positive 2 charge comes close or comes near to this nucleus with 79 positively charged particles, right? What do you think would happen here? It would of course repel from each other because positive and positive repel from each other. You have learned it through magnets as well. When you have south pole with south pole, they're gonna get away from each other, right? Same here, same in this case, okay? Positive 2 charge will repel from positive 9 charge and it will go in the opposite direction, or it can go to 170 degrees. It might deflect, it might go here, it might go somewhere else. It can deflect. The main point is it can deflect up to 180 degrees, okay? So this force that is causing this repulsion is known as electrostatic force. It can be either attractive force or it could be either repulsive force, okay? So in this scenario, it is a repulsive force, right? Positive 2 and positive 9, is causing a repulsion. This alpha particle is going away from this gold foil, okay? Or gold atom's nucleus, okay? Now let's check the options and let's see which of these options explain our observation, okay? Option number A says strong electrostatic force act on the alpha particle. It is true, as we have discussed that this electrostatic force, between the alpha particle and the nucleus cause it to move away, go away from each other. So A is correct. Now option number B says the atom is mainly empty space. Okay, I agree with you. Atom is mainly empty space. But does this explain our argument that these alpha particles are going up to 180 degree? Why they are going up to 180 degree? This statement does not explain that. So we can just cross it out. And option number C, it says the charge is evenly distributed in the atom. Okay, let's assume that all of the charges in this gold foil is, evenly distributed. The charges are evenly distributed. You have plus one everywhere, okay? Now, if the plus one, this is plus one and alpha particle is coming with a positive 2 charge, do you think it would make it go up to 180 degrees? Or it would make it deflect up to 180 degrees? No, it wouldn't. It wouldn't happen. So this option is absolutely incorrect, okay? Now we have option number D. It says the gold foil was very thin. Okay, the gold foil was very thin, but does it explain our statement or our observation that why the angles were deflected up to 180 degrees? No, it does not. So you can just safely cross it out as well. So you're left with option number A, and option number A is your final answer. Follow for more.